Let us look at again a problem of finding the integral using substitution method. This is going to be a substantial one. So tighten up your belts. So we have I is equal to integral of dx by ax square plus bx plus c, where a is not equal to 0. So let's take out the coefficient of x square, that is a. So 1 by a we have taken out. So integral of dx by x square plus b by ax plus c by a. Now let's complete the square in the denominator. What we get is x plus b by 2a the whole square plus 4ac minus b square by 4a square. Now let's add up these two. So we get 2ax plus b by 2a the whole square plus 4ac minus b square by 4a square. Now let's do a substitution. Let u is equal to 2ax plus b. Differentiating it, we get du is equal to 2a times dx, which implies dx is equal to du by 2a. So we end up with x square plus b by ax plus c by a is equal to u by 2a the whole square minus b square minus 4ac by 4a square. Let's multiply both sides by a to get back the original quadratic. So we have ax square plus bx plus c is equal to a times u by 2a the whole square, that is u square by 4a square, minus b square minus 4ac by 4a square. Let's cancel off one of the a's with this a. So u square by 4a minus b square minus 4ac by 4a. And combining these two terms, we end up with u square minus, within brackets, b square minus 4ac by 4a. So we have shown that these two are equivalent. Integrating dx by ax square plus bx plus c is equal to integrating du by 2a divided by u square minus b square minus 4ac by 4a. Simplifying that, we get du times 2 by u square minus b square minus 4ac. Let's now take 2 out. So we have 2 times the integral du by u square minus, within brackets, b square minus 4ac. Let's say d, capital D, is equal to b square minus 4ac. So our statement becomes integral of dx by ax square plus bx plus c is equal to 2 times integral du by u square minus d. Now here, remember, d can be less than 0, greater than 0, or equal to 0. So let's take the first case when d is less than 0. So if d is less than 0, that means we can say absolute value of d is equal to 4ac minus b square. Remember, we assigned d is equal to b square minus 4ac. Here we are talking of 4ac minus b square, and that would be greater than 0. Integral of 2 times the integral du by u square plus absolute value of d, which can be written as square root of absolute value of d square. So that means u square plus a square or something like that. And we recognize the pattern, u square plus a square. Pattern we recognize. So that integral is equal to 2 by square root of absolute value of d times arctan of u by square root of absolute value of d plus c. Again, substituting u now, we get integral of dx by ax square plus bx plus c is equal to 2 by square root of absolute value of d, which can be written as 2 by square root of 4ac minus b square times the arctan of u becomes 2ax plus b divided by square root of 4ac minus b square plus c. Now remember, this is the case when 4ac minus b square is greater than 0. Let's look at another simple case when d is equal to 0. So when d is equal to 0, remember we had reached this stage. So 2 times integral du by u square minus d is 0, which means we are left with 2 times integral of du by u square. And we know the integral of du by u square. So I is equal to 2 times integral du by u square is equal to minus 2 by u plus c. See, whenever you end up in a situation like this, where you are not sure whether this is actually the integral or not, just differentiate this. You should get back this. Okay. So therefore, integral of dx by ax square plus bx plus c is equal to minus 2 by u is 2ax plus b. Now this is when b square minus 4ac is equal to 0. Pretty straightforward. Now let's look at the third case, which is going to be a little bit more trickier. Now when d is greater than 0, let u is equal to square root of d sec t, where the absolute value of u is greater than square root of d. U is equal to square root of d sec t. U square minus d becomes what? It becomes square root of d sec t the whole square minus d. And here this square root disappears because of the square, and sec t becomes sec square t. So d sec square t minus d, and d is common. So let's take it out. We have d times sec square t minus 1, which is equal to d tan square t. Differentiating u is equal to square root of d sec t. We get du is equal to square root of d is constant times derivative of sec t is sec t tan t dt. 2 times integral of du by u square minus t is equal to, remember this is what we had ended up as part of the initial setup. So when we do the necessary substitutions, we get 2 times the integral square root of d times sec t tan t dt. This square root of d times sec t tan t dt is nothing but du. And u square minus d is d tan square t. We are root d, square root of d times square root of d is equal to d. So when we cancel these two, denominator, we will end up with a square root of d, which we take it out. So we have 2 by square root of d times integral of, now tan t, 1 cancels out. We are left with sec t by tan t dt, which is equal to 2 by root d times integral of sec t is 1 by cos t times tan t is actually sin t by cos t, but when we bring it up, it becomes cos t by sin t dt. Cos t cancels. We have 1 by sin t, which becomes 2 by square root of d times integral of cosec t dt. Now, 2 by root d times integral of cosec t dt is equal to 2 by root d times natural log of tan t by 2 plus c. Don't forget the absolute symbol. Now, we have already done this. U is equal to root d sec t. That means sec t is equal to u by root d, which implies cos t is equal to root d by u. Now that we have got cos, we can get sine easily. So sine t is equal to square root of u square minus d by u, by using this identity. There is a half angle identity for tan t by 2, which is equal to 1 minus cos t by sin t. Now we already know what is cos t, we know what is sin t. So let's incorporate that. tan t by 2 is equal to 1 minus cos t by sin t, which is equal to 1 minus root d by u, which is cos t. The whole thing divided by square root of u square minus d by u, which is sin t. And here we combine these two terms, we get u minus square root of d by u divided by square root of u square minus d by u. So this u and this u gets cancelled out and we are left with u minus square root of d by square root of u square minus d. Now we have got tan t by 2. So tan t by 2 we have. Now we take the natural log of that. So natural log of tan t by 2 is equal to natural log of u minus root d by square root of u square minus t. In natural logs, when we divide, we can convert it into subtraction. So this is equal to natural log of u minus root d minus 1 by 2 times natural log of u square minus root d square. Remember, this u square minus d under the square root can be written as u square minus d to the power of 1 by 2. And since it is natural log, that 1 by 2 comes down. And here I have mentioned this square root of d square just to give you an indication that we are going to use a square minus b square is equal to a minus b times a plus b. So again, remember, as of now, d is greater than 0. So d is positive. So there's no question of getting into imaginary numbers here. So in the next step itself, natural log of u minus square root of d minus 1 by 2 times natural log of, we are factoring it, u minus root d times u plus root d. Natural log of u minus root d minus half times natural log of u minus root d plus natural log of u plus root d. Products becomes additions in natural log. So now this is natural log of u minus root d. Here we have minus half natural log u minus root d. So 1 minus half becomes half. But that half is also applicable to this. So again we have common half. So 1 by 2 is common. So we take 1 by 2 out and we write natural log of u minus root d minus times plus becomes minus natural log of u plus root d. Again subtraction becomes division. So we can write it as 1 by 2 times natural log of u minus root d by u plus root d. So we have completed up to here. But now 2 by root d also has to be incorporated. So 2 by root d times natural log of tan t by 2 is equal to 2 by root d times 1 by 2 times natural log of u minus root d by u plus root d. This 2 and 2 cancels out. So finally we are left with 1 by root d times natural log of u minus root d by u plus root d. We have the integral dx by ax square plus bx plus c is equal to 2 times the integral du by u square minus d, which is equal to 1 by root d natural log of u minus root d by u plus root d plus c. U again has to be substituted. So we end up with 1 by root d natural log of absolute value of 2ax plus b, which is what u is, minus root d divided by 2ax plus b plus root d plus c. And this is the case when b square minus 4ac is greater than 0. So important points to consider. We have applied substitution method more than once. Once from x to u we have gone, and then from u to t. Not in all the cases, but we have seen how multiple substitutions can occur. And then we have three different integrals for the same integrand. depending on the discriminant d equal to b square minus 4ac. So our integrand was what? Integral of bx by ax square plus bx plus c, where a is not equal to 0. And we know d is equal to b square minus 4ac is the discriminant. This I'm sure everybody knows. Quadratic formula. In that it appears. So depending on whether d is less than 0, greater than 0, or equal to 0, we end up with different integrals. That was interesting, right? Let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.